model by collecting the data. And then the data is collected, you're using some econometric or statistical tools or packages, and then you're trying to finalize or get a value for it. What is it? You're trying to check the hypothesis. The hypothesis was law of demand. It's nothing but there's an inverse relation between price and quantity demanded. So hypothesis testing is nothing but after collecting the data, processing, when everything is done, then finally you're checking whether your hypothesis is now tested with the results. And then comes forecasting. Forecasting is nothing but what you're doing. If this is the price, what happens to the quantity demanded? Or what happens if the demand is going to increase in future? With that, we'll do the forecasting. Forecasting, I will definitely show you now with an example itself what is forecasting. So quickly, I'll do this. 15 minutes, I'll go through all these things, and then we'll move back with the empirical part, or we'll do a practical session also. So types of data, past 3 days, the resource persons insisted on this only. So different types of data. Yesterday also ma'am spoke about all these things. A small recap. Quickly I'll have a recap of this, so that we'll while doing you'll get you'll be a little fresh. So what is time series data? Data collected over a period of time and arranged in chronological order. So data over here, you can see the time series data. So this is data collected for 2014, 15, 16, 17. It is a time involved. The time must be equal. So it is 1 year, yearly data. So time series data can be yearly, monthly, quarterly, half yearly, 5 years data, even decadal data, 10 years data. You have census data, or it can be intraday data like gold and silver, morning and evening, or even hours data, minutes data like stock prices. So all these are time series data. The only thing which have to be noted here is the time interval must be equal. So here, the table over here, you have the year, country, GDP and population is given here for Vietnam. It can be even for India, anything you can have. So this, I think the table over here is quite visible. So this is time series data. Second comes the cross-section data. Cross-section data is nothing but data collected at a particular point of time across subjects. Data collected at a particular point of time across subjects. Very simply, if I want to put in words, you're entering into a doctor's clinic. Okay, there's a person sitting over there to collect the data on what is your name, your age, your assuming that he's taking a BP also, and your weight. So what is it? From 6 o'clock, people are entering till 8 o'clock. So that becomes a cross-sectional data. Data collected at a particular point of time across subjects. So there can be 50 or 100 patients coming inside from 6 to 8 p.m. And that data which is collected at that particular point of time is cross-sectional data. Hope it is clear. Panel data or pool data. Panel data is nothing but data. It is a combination of time series and cross-section. So the table over here, what did we say? We said 2015 we had the data for India, 2015 and 2016, assuming 2 years I'm having for India. And then for same 2015, 2016 I'm having for Sri Lanka. When you combine like this, okay, again 2015, 2016 for Bangladesh. So if you combine data like this, it becomes a panel data. So here, time interval is equal, 15, 16, 15, 16, 15, 16. So this is balanced panel. So assuming I'm having for Thailand only for 2016 or 2018, it is only for 1 year, then it is unbalanced panel. So packages like eViews, Tata, all these work with a panel, exclusively they work for panel data. So balanced and unbalanced, now in the current version is Tata, I had it from 8th, 9th version itself. Balanced and unbalanced panel was, we can work out over there. Practical section I'm telling. And eViews, you can work it out, and R language, Python, all can work panel data. That's very simple. And so now we spoke about types of data, and we are having something called as univariate and multivariate data. Yesterday, ma'am, she spoke about ARIMA model, the resource person. She gave an excellent speech on ARIMA model. So that was a univariate data. Univariate data is a single variable. Okay, assuming I'm having a data like 7, 12, 19, 25, 8, or 30. Okay, this is a data. Very simply, this is a data. What can you do with this data? Can any participant willing to give an answer for this? Just few seconds, or else I'll move with this. So the data is given in front of you, 7, 12, 19, 25 and 30. Do you think anything can be done with this type of data? Or do you call this as a data, first of all? Yes, no?
Yes, ma'am.
Yeah, thank you. So you can do something with it. This is called as data. You can do something with this. What can be done? You can draw a graph. You can find mean. You can find a median, mode. Anything can be done. So this is the univariate data. A single variable is there. Look over here. This side. I'm having height of you students. Okay, this is a univariate data. And then we have bivariate data. Bi means 2. More than 2 means multivariate data. Here I am having data for height and weight. So you are having 2 data. So this becomes bivariate. Then you have multivariate data. And yesterday when ma'am spoke, ma'am gave you spoke about stationarity and non-stationary data. What did we say about stationary and non-stationary data? So quickly, this is the graph which ma'am showed you, and now I'll draw and I'll show you how you call it as stationary and non-stationary. Okay, stationary data, you're just plotting the data. This height, if I'm going to plot something like this, this is non-stationary data. You're plotting the data like that. It becomes non-stationary data. When you want to make a data stationary, you're taking a first difference technique. The stationary data means it is a mean reverting process. You can see here, zeros here. So what is it? If zeros here means it is a mean reverting process. You have like this, the data moving like this. When you take a first difference technique, your data moves like this. So in Excel also, I'll show you how it is moving. I'll take a small sample and I'll show you if time permits. So this is what which ma'am said yesterday about stationary and non-stationary. Then moving on to this is time series which ma'am spoke yesterday about trend, seasonality, cyclic component and irregular component. Trend, you know that it generally has a trend, a general movement of a data. A trend means you're having a data, you're plotting a data like you had height or weight or GDP, something you're plotting with respect to time, or your sales data also can be there.